Hi students, my name is Miss Cassandra Lindbergh Finance, and in this grade 9 geography lesson, we'll be discussing a very important topic, plate movements and boundaries. Before we go into mountain formation, let's do a brief review on the structure of the earth and on plate tectonics. The earth is divided into 3 layers. And we discussed this in our last lesson, where we noted the core, which is the innermost part, then there's the mantle, and finally there's the crust, which is the outermost part of the earth, as illustrated in the diagram. The earth's crust is divided into huge plates. These plates float on the mantle, and they're always moving. Their movements are caused by waves of magma or molten rocks, which pushes the plates along as they rise, cools, and sink back to the bottom again. Again, in our last lesson, we spoke of this as convection currents. This causes the plates to either pull apart, collide, or slide past each other. Most of the world's landforms occurs at plate boundaries. Volcanic and mountain building zones are also located at plate boundaries. There are 7 major plates, and they make up our continents. And there are also 10 minor plates. These include the North and South American plates, the African plate, the Antarctic plate, and we can go on. If we look at the diagram, we can see all the other plates that exist in our earth. In the diagram also, we can see arrows, and these arrows indicate the type of movement. Here we see plates are moving side by side in the same direction. Plates are moving away in opposite directions. Plates are coming together from opposite directions. Take a minute and carefully look at the arrows. Identify where they're moving. Are they moving side by side? Are they moving alongside each other, away from each other, or are they moving together? Always note the following. Continental crusts or plates cannot sink. Oceanic plates does. And it happens because they are heavier or they are denser. Plates cannot overlap. They can only be pushed upwards or pushed downwards. Once they are pushed upwards, they form what is called mountains. Once they are pushed downwards into the mantle, they are destroyed. Another fact to note is that there are no gaps in the Earth's surface. There are no spaces in the Earth's surface or in the Earth's crust. Therefore, when plates pull apart, new oceanic crust from the mantle is formed, and that fills whatever space is created. So at no time, there are gaps in the Earth's surface. Now, with this foundation, we can now move right into plate movements. Now, there are 3 different plate boundaries: compressional, also known as destructive plate boundaries. Here, either two things can occur. And what are these two things? They can either create subduction zones or collision zones. Let's explain them further. And we'll start with what occurs at a subduction zone. When an oceanic crust moves towards a continental crust, can you remember the rule? Which will sink? Simply because it's heavier. Yes, oceanic crust will sink into the mantle and form deep trenches and island arcs. Okay, students? From the rule, we remember that oceanic crusts, they are heavier. And as a result, when an oceanic crust meets a continental crust, one will sink. And the one which will sink is the oceanic, simply because it is heavier. As it sinks, it forms deep sea trenches and island arcs. The second aspect is what occurs at collision zones. When two continental crusts collide, neither can sink. In fact, because both have the same density, they are forced upwards. And in being forced upwards, they form what is called fold mountains. The other type of plate boundary is called tensional or constructive or divergent plate boundaries. Here the two plates move away in the opposite direction as illustrated in the diagram above. This type of movement mostly occurs under the ocean. What do you think happens as these plates are moved apart? We also dealt with it as a ground rule. Remember, there never can be gaps in the Earth's crust, right? So, as the plates move apart, the gaps are filled with magma, and this magma rises from the mantle below. In the process, they create what is called shield volcanoes. Finally, the third type of plate boundary. This type of plate boundary is called conservative or passive, or sometimes it's referred to as transform plate boundaries. Here the two plates are sliding past each other as they move in different directions. This causes pressure to build up along the fault until one plate jerks past the other, causing what we know as earthquakes. In other words, whenever there is an earthquake, remember it's because two plates, two continental crusts are passing each other. And as they pass, force is built up between them, and in order to make a freeway, they jerk past each other. And in the process, this causes earthquake. Land is either formed or destroyed in this process. To summarize our lesson today, in this session, we did a brief recap on the structure of the Earth, where we were reminded that the crust is separated into plates, which can either be oceanic or continental in nature. We then look at how plates move, and we noted that there are three types of boundaries: constructive, destructive, and conservative plate boundaries. Finally, we looked at resulting landforms. Use a well-labeled diagram to explain the following and their forms. For example, 1. Seafloor spreading. 2. Continental rifts. 3. Hotspots. And 4. Subduction zones. This has brought us to the end of our lesson, where we looked at plate movement and boundaries. I am Miss Cassandra Limburg Finance. See you in our next session, where we'll be exploring another interesting and exciting topic. Bye, students.